Okay, let's start again. My other video started lagging, so let's look at the geometric sequences. Geometric sequence is by multiplication of a common ratio. Now with arithmetic, it was the addition always of the difference, of the common difference. Now the difference could be addition of 2 or subtraction of 2. But here we can only multiply by the common ratio. So that's something different in geometric versus arithmetic. Now the other pieces, a of 1 is still the same as before, it's the first term. N is always the nth term, and geometric is always done by multiplication. So this is for something that maybe the series is being multiplied by 2 or multiplied by 3. Then you need to write the formula or form. Because of a geometric, it's going to be slightly different. Now, looking at this is the formula, by the way. It's the given geometric general formula. Now, I can take that and adapt it for any geometric sequence. First, you got to know it's geometric versus arithmetic. So given this item, I have 1 and then 1/3, 1/9, 1/27, 1/81. If you try to do a plus 1/3, this next one here would be 1/3 plus 1/3 is 2/3. So I know that I'm not adding something. In this case, I have to be multiplying it to make it work. It asks to find the nth term of the geometric sequence. So I'm going to have to write the general formula of the sequence. And remember, I need my A1 and I need my R. When you're writing the general formula of any specific sequence, we're always filling in the first term and the common ratio or common difference if it's arithmetic. But we leave n as n in the general formula. So let's figure it out. I know that A1 is 1. And then to find R, we divide the two terms, any two terms. So to do that, I would go, all right, if I did R, I want to find R, I may take the second term divided by the first. So that's 1/3 divided by 1, which is the same as 1 over 1. Copy dot flip, I have 1/3 times 1 over 1, and I get 1/3. Or maybe you're not absolutely certain that you did that right. So say that I double check. I need to double check. I can take any two. So maybe I'll take term 3 divided by term 2. They have to, when I say any two, they have to be the one and its predecessor. It can't be, let me rephrase that. You'll always want to take one of those terms and its predecessor, because remember, a common difference was always between those two terms, and then you check between the next two terms. Well, common ratio is done the same way. I need to take two terms together. So I could take term 1 and 2, which I did, and then term maybe 3 and 4. Or in this case, I'm going to take term 3 and term 2. You always take the second term of the group of 2 divided by the first term. So I have 1/9 divided by 1/3. I can't go the other way. I need to go always the later term divided by its predecessor. So this is going to be 1/9 times, flip side, 3 over 1, and then I reduce and I get 1/3. So as you can see, as long as you set it up right, you can always find that ratio if you have at least two terms. Then my final answer for the general formula of the sequence is going to take this item up here and place in your A1 and your R, but leave n as n. So I can use it for any position I want. Now, A1 is, again, 1. Do I need to have that 1? I don't. But I'm going to put it in at first. My ratio is 1/3, and this is n minus 1. Or you can just write it as A of n equals 1/3 to n minus 1. If you had a problem given like this, you would know that the A of 1, your first position, would have to be 1 because nothing else is notated there. So there's my answer for example 1. Now let's do the next one. The third term of a geometric sequence is 63/4, and the sixth term is 1701/32. Find the fifth term. Okay, I'm going to push this up a little bit. That's always scary. Let's highlight what we know. We know the third term is this much, and the sixth term is this much, and I need to find the fifth term. Well, before I can find any specific term in the sequence, I need to know my A1 and my ratio. I don't know either yet. But like we did in arithmetic, I can say, oh, well, the third term equals 63/4. So I know in the formula above that we just saw, it would be A of the third term. So my output of my third term is going to equal A of 1, which we don't know. Ratio, I don't know, of n minus 1. Well, n I do know. It's 3. Therefore, let's reduce that down. I also know that A of 3 is the third term. Remember, the third term means it's A3. So A3 is 63/4 equals A of 1 r to the 2. So far, I still have 2 unknowns. Now let's go to the other item I know. I know the sixth term. Well, that equals this crazy number of 1701/32. Let's fill in what we know. So this would mean A of 6 equals A1 to the r, or times r to the 6 minus 1 power. Well, let's plug in what we know. Again, this is your A6. Sorry, my paper keeps moving. That's A6. Place it in place where it's at. 1701/32 equals A1 r to the 5th. Now I have 2 equations with 2 unknowns, A1 and r. This is a system of equations. That is a system of equations. We know how to solve a system of equations. It might not be extremely pretty, but we can do it. So our first item up is we need to solve the system, just like we did in arithmetic. Now you can use substitution, elimination, which I used last time, and in this case, because it's geometric, I can use division, or what is considered a ratio. Because of the geometric sequence, I can't do that one on the arithmetic because arithmetic does not have a common ratio. It has a common difference, so we can't use that there. This one will be easier to use with the ratio option. So I know if I do 1 over the other, that's a ratio. I personally am going to do the later divided by the earlier term. So that would be 1701 divided by 32 equals A1R to the fifth divided by 63 over 4 equals A1R to the second. Well, let's talk about that. These two things are being multiplied. Maybe I'll put the dot there now. Okay, those are being multiplied. Inverse of multiplication is division. Anything divided by itself is 1. That gives me R5 over R2. Now we need to think, how do I do exponents? My laws of exponents say if you have two of the same base, these are the same base, to an exponent, we can use our laws of exponents to do that. That would make R5 divided by R2 would actually be R3. I'm going to flip it around to put the R on the left-hand side. Subtraction of exponents when it is in a division item. So you can't forget this material. And then that's going to equal my top divided by my bottom, the numerator divided by the denominator. That would be 1701 over 32. And because it's division of a fraction, copy dot flip, and this would flip to 4 over 63. Personally, before you start plugging that into a calculator, I would try to reduce. You can see that 4 and 32 are really easy to reduce, and it would be 8. I always check, can 63, because it's quite large, and this one's quite large, can 63 go into 1701 evenly? Anything from the top and the bottom can be reduced. I tend to do that. And I found out that it does. So I have 27 over 8. You can do it the old-fashioned way and multiply and then reduce, but it's going to be less time-consuming if you do the reduction first. And then, okay, so this means R third equals 27 over 8. But I need R, not R third to the third power. So how do I get just R? Well, I do the opposite of what cubed is, which would be cubed root. And whatever I have on one side, I'm going to have on the other. So the cubed root, it was a positive to begin with. Remember odds, we don't have a plus or minus, it's just whatever it is. And I then have, in the end, R is going to equal 3/2. I found my R value. But remember how I also need to find A. So the next thing I'm going to do is then, maybe I'll back this up, then use one of the two original equations that you found. Well, I'm going to use equation 1 because it's smaller than equation 2, and I don't want to deal with that bigger fraction. So I'm going to use equation 1. And I'm going to find, I should say, use that, find my A of 1. So plug in your information. I have 63 over 4 equals A1 times the ratio 3/2, and remember this is squared. Order of operations, I'm going to square this first. So this becomes 63 over 4 equals, and this is A1 times 9/4. Then my A1 is going to be 63 over 4 divided by 9/4. So if I'm dividing by a fraction, it's copy dot flip. So I have 63 over 4 times flip side 4/9, and you can easily see if I reduce, my A1 is going to end up being 7. Great. Now I can find the specific general form. So find the specific general form for this sequence would be, let me underline that, it's going to be my R and my A1 put in, but not in. I need in to stay in so I can plug in any value I want to find or any term I want to find. So I have A of n equals my A1, that's 7, times its ratio, which is 3/2, to the power of n minus 1. Great. I have my specific form. I can find the 5th term, the 500th term, the 1000th term, whatever I want to do. And in this case, back in the question, it said to find the 5th term. So therefore, the 5th term, we would use that formula. Plug in 5 for n. So I have A of 5, that's your output, equals 7 times 3 over 2, and then have 5 minus 1. That's going to equal 7 times 3/2 to the 4th power. Do your calculations, you're going to get 567 over 16. That is the 5th term in the sequence. That one is done. We're going to move on to partial sums of a geometric in the next video.